In the warm-up, we found the area of two-dimensional shapes, and then we introduced the idea of volume as being the amount of space a three-dimensional object takes up by looking at the two-dimensional object and imagining as though we stacked up that two-dimensional object to make a 3D shape and found the volume of that. So basically the way we did that is we found the area, we took the area of the two-dimensional figure and just multiplied it by whatever the height was. So that's the basic way to find the volume of any type of prism. Okay, so today we're going to learn how to find the volume of rectangular prisms, triangular prisms, and cylinder. So the cylinder is basically like a circular prism. A cylinder just has its own special name. Okay, so first looking at the rectangular prism, the way we find the volume is we take the area of the base and we multiply it by the height of the prism. So a rectangular prism, the base is a rectangle, and it has dimensions length and width. The height of the prism is basically how high we are stacking the rectangle. So in this case, the height is vertical. So this is the height. So to make it a little bit more specific for a rectangular prism, the way we find the volume, well, the area of the base, the base is a rectangle, and the way we find the area of a rectangle is just length times width, and then we multiply that by the height. So you can say the way you find the volume of a rectangular prism is you just do length times width times height. So you basically just take the three numbers and multiply them, and that's the volume of the rectangular prism. So let's look at an example. Okay, here's a basic example. It's a rectangular prism, so we have our base. Remember, base does not always mean bottom, but with a rectangular prism, you can highlight the bottom since every side is a rectangle in a rectangular prism. And the height is how high stacked the rectangles are, and that would be that measurement right there. So we have our length, we have our width, and we have our height. So to find the volume, it's just length times width times height. So it's just going to be 6 times 3 times 4. You get a volume of 72. And remember, the units are always cubed for volume. So 72 centimeters cubed. Okay, so now let's take a look at a word problem. So example 2 states that a rectangular prism with the dimensions 11 by 14 by 5 is melted into another rectangular prism whose width is 5. Find the length and the height of the new rectangular prism if the length equals the height. So the main thing we need to understand about these two is if you think of this like a cube of ice, if we were to take this cube of ice and let it melt and then pour it into another cube and let it freeze, these two would have the exact same volume. So these have equal volumes, which means if we know the volume of this one, we can use that to find the dimensions we need for our new figure. Okay, so now let's label what we know. So in here we know that the dimensions of our original prism is 11 by 14 by 5, which could just be the length, the width, and the height. And then in the new triangle, we know just the width is 5. But we know that the length and the height are both equal, so we're just going to call those both x. So the length is x and the height is x. Okay, so I can find the volume of the first shape. Oops, this shouldn't say h, sorry. This should say 5. I can find the volume of the first shape by doing length times width times height, so 11 times 14 times 5, which is a volume of 770. And the volume of the second shape is just going to be x times 5 times x. So we can simplify that to 5x squared, since x times x is x squared. Same thing as saying 5 times 5 is also 5 squared. Okay, so the volume of the second one is 5x squared. Well, since we know that they have equal volumes, I can set the two volumes equal to each other. So 770 equals 5x squared. So now this just becomes a simple algebra problem. We just need to get x by itself. We're going to divide both sides by 5. So we have x squared equals 154. And then to get x by itself, we need to undo that exponent, and we do that by taking the square root. So you get x is about 12.41. So since this is a word problem, it needs a word answer. So the length and height of the new rectangular prism is 12.41, and since there are no units here, we're just going to say units. So it's not units cubed because we weren't solving for the area, or sorry, we weren't solving for the volume, we were just solving for a dimension, which is why it's just units, not units squared or units cubed. All right, so now let's take a look at triangular prisms. Okay, so a triangular prism has a triangular base. And remember, base does not always mean bottom, because in this second one here, the base is not the triangle. That base is a rectangle. The base of the triangle is actually this part that's facing us right here. So this right here is the base. Okay, and the dimensions of the base, the bottom part of the triangle, we use a lowercase b, and then we have the height of the triangle, which we use a lowercase h. So same thing with this one. The bottom of the triangle is a lowercase b, that's the base of the triangle, and then we have a lowercase h, which represents the height of the triangle. So there's a difference between triangle and triangular prism. Triangle is the flat shape, triangular prism is a three-dimensional shape. Okay, then in these triangular prisms, we have the height, so that's basically how many stacked triangles we have. Okay, so in the first one, the height is actually vertical, since the base is on the bottom. So our triangular shaped pancakes are stacked up. In the second one, since it's on its side, our height actually goes back. It's how far back our shape goes. Okay, so to find the volume of a triangular prism, it's basically the same idea. It's the area of the base times the height of the prism. Okay, so a little more specific to a triangular prism, the area of the base, since it's a triangle, is 1/2 little base times the height times the height of the prism, which we use a capital H. So the volume of a triangular prism is 1/2 times the little base times the little height, that's the area of the base, times the height of the prism, which is a capital H. Okay, so basically what we do for a triangular prism is we just take half of what we get when we multiply all three dimensions. Okay, so let's look at example number 1. So here is a triangular prism, and this is a triangular prism that's on its side. So a triangular prism has a triangular base. So this right here is my base. So the dimensions I have of my triangular prism is I have 4, which is my little base. And then we need the height. So remember, the height is the one that's perpendicular to the ground. So 7 represents this height, which we call the slant height. We don't need that measurement. The 6 is the actual height of the triangle. It's the height that goes straight up and down. Okay, then we have the height of the prism. So in this case, the height goes back since it's on its side. So this is our capital H. Okay, so the 7 we don't need because that's the slant height, but that doesn't help us find the area of the base. So to find the volume of a triangular prism, it's 1/2 times the base of the triangle times the height of the triangle times the height of the prism. Okay, so just plugging in what we know now. It's 1/2. 4 is my little base, so times 4. My height is 6. And then my height of my prism is 12. So 1/2 times 4 times 6 times 12. So you can use 0.5 instead of 1/2. You should get 144 centimeters cubed. All right, let's look at example 2. So example 2 says the volume of a triangular prism is 154 centimeters cubed. The base of the prism has an area of 36 centimeters squared. What is the height of the prism? So this is a working backwards problem. The reason I know this is a working backwards problem is because they start by giving us the volume of the shape. Okay, then they go on to give us the area of the base, and we're solving for the height of the prism. So remember, the basic formula to find the volume of any prism is just the area of the base times the height of the prism. So plugging in what we know the area or the volume, that's 154. We know the area of the base, that's 36. But we don't know the height of the prism. That is what we are solving for. So we're just going to call that H. So once you plug everything in, like before, it just becomes a simple algebra problem. We just need to get H by itself, so we're going to do that by dividing by 36. So 154 divided by 36, you get about 4.28. So word problem, my word answer is the height of the prism is 4.28 centimeters. So again, this isn't centimeters squared or centimeters cubed because this is not area or volume. This is just a dimension. It's just one part of my triangular prism. All right, my last example, or my last one, is a cylinder. So for a cylinder, the base shape is a circle. And again, base is not always on the bottom, but for a cylinder, it will always be a circle. The dimension that we need in a circle is just the radius. Remember that sometimes you are given the diameter, and if you're given the diameter, you just have to divide that by 2. Okay, then the height of the cylinder is just however many stacked pancakes you have. So that would be the height. So sometimes height is not up and down, but sometimes it's sideways, which in this case, since our shape is sideways, the height is sideways. All right, so to find the volume, just like all the other ones, it's the area of the base times the height of the cylinder. Okay, so to be a little bit more specific, to find the volume, the area of the base, since the base is a circle, that's pi r squared, and then times the height of the cylinder, which we use capital H. So to find the volume of a cylinder, we use pi times the radius squared times the height. Okay, let's look at example 1. So in this case, I'm going to highlight my base, which is this circle right here. In this problem, we are given the radius, and then the height is this sideways one right here, so this is the height. So to find the volume, it's going to be pi times the radius squared times the height. So let's plug in what we know. It's going to be pi times 6 squared times 18, which is my height. So remember, with any problems involving circles and pi, I do want you to give two answers. I want you to leave your answer in terms of pi, but I also want you to get the approximate answer when you multiply by 3.14. So to get my answer in terms of pi, we ignore the pi and just work with the numbers. So 6 squared is 36, and 36 times 18 is 648. So my answer in terms of pi is 648 pi inches cubed. And then to get my approximate, we're going to do 648 times 3.14, which is pi. So for the approximate answer, you should get 2,034.72 inches cubed. So this top one is my exact answer, and this one is my approximate answer. Okay, let's look at example 2. So this one says the volume of a cylinder is 576 centimeters cubed, and the height is 16. We want to find the radius of the cylinder. So just like the previous one with the triangular prisms, this is a working backwards problem. The reason I know this is a working backwards problem is because we're given the volume and we're asking for a dimension. So volume of a cylinder is pi r squared times the height. And now we're just going to plug in what we know. We know the volume, which is 576 pi. We don't know the radius, that's what we're trying to find, but we do know the height. So that's 16. So now it's just a little bit of algebra to get r by itself. So the first thing that's going to help you out here is that if you have pi on both sides, you can actually just cross them out, because basically what we're doing is we're dividing both sides by pi. And when you divide both sides by pi, it cancels out the top and the bottom. So you're left with 576 equals r squared times 16. Okay, so to get r by itself, we first need to get rid of that 16 by dividing. So we get r squared. 576 divided by 16 is 36. And the last thing we need to do is take the square root of both sides to get rid of that exponent. So we get r equals 6. So the radius of the cylinder is 6 centimeters. Okay, now I'm going to go over a few of the practice problems. So 1B, we're dealing with oblique shapes. So remember, oblique is when it's kind of slanted. So for part B, this is an oblique cylinder. The way we find the volume of an oblique shape is basically the same way we find the volume of a regular shape. All we need to do is make sure that the height that we use is the height that is perpendicular to the base. So in looking at B, the base is a circle. So we have the radius. And the height is not going to be what we call the slant height. This is not the height. The height is how high it is perpendicular to the ground, which in this case is going to be this 5. So this is going to be the height that we're going to use. So the way we find the volume, since it's a cylinder, is just going to be pi times the radius squared times the height, and we're just going to plug in what we know. So it's going to be pi, my radius is 2 squared, times my height, which is 5. So my answer in terms of pi, I'm going to do 2 squared, which is 4, and 4 times 5 is 20. So 20 pi inches cubed is my answer in terms of pi. And to find my approximate, I'm going to do 20 times 3.14. So 20 times 3.14 should get 62.8. So my approximate answer is 62.8 inches cubed. So oblique shapes, we find the volume as though it's a regular shape, but make sure we just use the correct height. The height that we need is this height right here. If you are given this height, you can use Pythagorean theorem to find the height that you need. Okay. So now let's look at 2D. So this is a composite figure. It's basically a three-dimensional shape made up of two different shapes. So in 2D, the two shapes that we see here is this bottom part right here is basically a rectangular prism, and the top part is half of a cylinder. Okay, so this top part is half of a cylinder, and the bottom part here is a rectangular prism. Okay, so let's do the easy part first. Let's find the volume of the rectangular prism. And the way we find the volume of a rectangular prism is just length times width times height. So this is my length, this is my width, and that's my height. So the volume of the bottom part is just going to be 9 times 11 times 6, which is 594 millimeters cubed. Okay, so now we need to find the volume of the half cylinder. So what I'm going to do is I'm going to find the volume of it as though it is a whole cylinder, and I'm just going to divide that by 2. Okay, so in looking at this top part, it looks like we don't have the measurements that we need, but whatever measurements are down here are the same up here. So this part right here is 9, and this part right here is 11, which are the only two dimensions we need for a cylinder. So if this part that goes all the way across is 9, that means our radius, which goes from the middle to the edge, is going to be 4.5, which we just do 9 divided by 2. So this is our radius, and the 11 represents the height of my cylinder. Okay, so to find the volume of my cylinder, it's going to be pi times my radius, which is 4.5 squared, times the height, which in this case is 11. So 4.5 squared times 11 is 222.75. So 222.75 pi. And then we're going to get the approximate answer because you can't add together something in terms of pi and just a number. We need to have them both be numbers. So 222.75 times 3.14. You get 699.44 approximately. Remember, that's the volume as though it is a whole cylinder, but since it's half a cylinder, we're going to divide that by 2. So you get 349.72. So this represents the volume of the top part, and this represents the volume of the bottom part. So to find the total volume, we're just going to add those together. So 594 plus 349.72. You should get 943.72 millimeters cubed. All right, now let's take a look at the last one here, number 3. It says how much salsa has been eaten. So really what we're trying to do is we're just trying to figure out how much empty space we have in this can. Okay, so what they give us the height of the can, and they give us the height of the salsa, and they give us the radius. Well, if we just want to find the air, we can get the height right here of the amount of air, and that's just going to be 10 minus 4, which is 6. So that means there's 6 centimeters of air. So really, if I kind of redraw this, this is what we're trying to find. This is 6 centimeters, and the radius is 5 centimeters. So that is the volume of the cylinder that we are trying to find. So since it's a cylinder, its volume is pi r squared times the height. So it's going to be pi times 5 squared times my height, which is 6. So 5 squared is 25, and 25 times 6 is 150. So 150 pi centimeters cubed is the volume of the air. That's in terms of pi, or that tells us how much salsa has been eating. To get the approximate answer, I'm just going to do 150 times 3.14. You get about 471 centimeters cubed.